Yeah.
Hi, everyone. Sorry we're getting started a little bit late here today. A few scheduling, minor scheduling issues to work through there. We're lucky today to have Emily Cox and Steve Westlake here to talk with us. They are two of the authors on a recent Nature Energy paper on the spillover effect of the term fracking. So I will pass this off to Emily.
Great, thank you. I'll share my screen if that's okay.
Yes, please.
Can you see that okay?
Yes.
Yeah, okay. Is that advancing? Yeah.
Yep, looks perfect.
Okay, perfect. All right, great. Yeah, thank you so much for inviting us to come and talk. So yeah, we're joining you from an extremely sunny south of the UK at the moment. And so yeah, so we've been doing some work on the controversy over fracking. I should say it's not just the term fracking, it's the entire controversy and all of the effects that were associated with it that we're interested in. So this goes way beyond just the word fracking, right? It's a lot deeper than that. But anyway, so we were interested to see kind of what impact this shale gas controversy has had. And one of the things that we looked into was its impact on other energy technologies. One of the things that we looked at was geothermal energy. I'm going to present, I've got some slides that we wrote. Before I do that, I'm going to present some work that some of my colleagues have done. First of all, I want to give a little bit of context about geothermal energy in the UK in general. And then I've also got some kind of background information, which I think would be really useful. My colleague, Derek Evanson at Edinburgh University, has been doing a project that was funded by the same group as we were funded as. But he's been looking specifically at perceptions of geothermal energy without including the perception spillover bit. Also just a note on where the kind of funding for this project came from. And so this was originally a large research consortium that was looking at unconventional hydrocarbons in the UK energy system, hence the acronym UKUH on the logo up there. About a year into this project starting, the UK government announced a moratorium on unconventional hydrocarbons. It announced a moratorium on fracking in the UK, joining many other European nations and also joining the devolved administration, so Wales, Scotland and Northern Ireland, in implementing a moratorium, right? And so this project found itself a year into the research in a political situation where unconventional hydrocarbons in the UK energy system were going absolutely nowhere, right? And so this project needed to redirect itself, I guess. And one of the things that it really wanted to focus on was what we can actually learn from the controversy over unconventional hydrocarbons, over fracking. What can we actually learn from that whole situation to bring to our understanding of other technologies? And this is how we ended up studying deep geothermal, because one of the areas in which the project kind of decided it was interested in looking is what can we learn and take forward into our understanding of geothermal energy. Anyway, so on to a bit of context. I'll bring Steve in a bit when we start to talk about our own work. So geothermal technologies are currently extremely minor part of the UK energy system. And this comes from a recent parliamentary briefing that was written about it. These briefings are very, very good. They kind of summarize all of the existing knowledge that there is. We know that the resource exists across the whole country, but we know that it's currently very underutilized. There's much lower current usage than most other European countries. The map on the left is actually heat pumps. These are ground source heat pump installations, and the numbers are pretty low, in the sort of lower than 10 in most areas, right? Also worth noting is that under UK law, geothermal's not currently recognised as a natural resource. This is something that a lot of geothermal actors are working on, but what it means is that there's no bespoke regulation. Geothermal's regulated by an awful lot of other policies, under an awful lot of other sectors, but there's no regulation that applies specifically to geothermal. And one of the concerns of actors in this space is that this might appear as though there's actually no regulation at all, and as though it's under-regulated and therefore under-controlled, I guess. The parliamentary briefing points out that there's a lack of long-term targets, there's a lack of supporting policies in the UK. When it comes to other geothermal resources, so the one on the left is mine water and the one on the right is deep geothermal. And so the UK has a legacy coal industry. The vast majority of coal sites are now closed. So we have all of these disused coal fields. There is geothermal resource in some of these coal fields, and there are currently several larger projects in development. Sorry about the unexplained acronym on the slide. BGS is the British Geological Survey. And not only are there several large projects in development, but they've also established a research site specifically for investigating the sustainability and the environmental impacts of exploiting these resources. And the other one is deep geothermal. And so we know that there's huge theoretical potential in the UK. In theory, estimates suggest that 2% of enhanced geothermal system resource could cover UK energy demand for more than 1,000 years. And I should say, this is from Parliament, right? So this is a relatively conservative estimate. This isn't even the highest of all of the estimates that exist. However, of course, it's extremely limited, particularly by the lack of supporting policies and the very high capital cost. It's been suggested that we could have a target for 500 megawatts of installed power generation capacity, but there's currently none operational. The pink bits on the map on the right are the areas that are currently looking most promising for deep geothermal. Mainly, it's this little bit in the bottom left-hand corner, right? The Cornwall area is where most of the attention is currently focusing. There's 2 projects under development, 2 sort of exploratory projects, if you like, and there's 4 more planned, all in the Cornwall area. So anyway, so that's a little bit of sort of background context, I guess. So moving on, so this is Derek Evanson's work, and he looks at support for various approaches to energy development. This survey was done longitudinally, so we've got data from 2021 and we've also got data from 2022. And I guess the headline message that we get from this is that geothermal seems to sit somewhere in between renewable resources, which are strongly supported by a very large majority of the UK population, versus fossil resources such as shale gas and offshore gas. Geothermal sort of seems to sit in the middle of those. And also just worth flagging this quite high proportion of sort of don't know responses. Therefore, you know, they find from these surveys that people are generally unfamiliar with geothermal. This unfamiliarity doesn't lead to them to pose it as such, but it does lead them to respond that they just don't know enough to answer the question, right? This was some more work that they did, essentially showing the same thing. And so they show that when people think about deep geothermal, perceptions are correlated with those of fossil resources such as shale gas. At the same time, they're also correlated with perceptions of renewables. So it sits in this kind of liminal space in between the two. We see that it's also got correlations with climate beliefs. However, unlike renewables and offshore and shale gas, the correlations are very, very minor and mostly non-significant. So what that basically means is that perceptions of geothermal are not as correlated with beliefs about general climate change as they are for the majority of other energy technologies that we might see in our energy system. They also did some work where they asked people their open-ended associations, right? And this is where it kind of leads into the work that I'm going to present in a bit. So more than 10% of their sample mention fracking when they get asked for their kind of top of mind associations with geothermal. This means that the notion of fracking is kind of, for this collection of participants, it's a minority, but it's still a relatively sizable minority. These people are making an instantaneous association with the word, fracking and geothermal. That said, they also find that there are lots of people who make associations with renewable and with green energy references as well. The most common response, however, is just about extracting heat and using rocks. And so these are quite technical associations. It's talking about the process itself without necessarily being attached to any sort of emotional response or any kind of opinion about it. And this on the right is just showing where people get their sources of information. And it's showing that things like independent bodies like the British Geological Survey and university scientists are very highly trusted to deliver information on these things. Whereas newspapers are actually the least preferred for people to get information. Just very quickly, here are some associations that people made with deep geothermal. So this is, people were asked for their top three things that come to mind when they hear about deep geothermal energy. And we can see that, and the size of the word corresponds to how many people mentioned it. So that we can see that fracking is really quite a big one here. But then we've also got like non-valent terms like energy, like heat, like the earth. And we've also got, to a lesser extent, words to do with renewable energy. And we've also got some other words, you know, we can see that some people said expensive, at the same time other people said cheap, right? And we can also see these associations with Iceland and with sort of, I guess, natural sources of this kind of energy, like volcanoes. This is the mine waters. And so people asked what they thought when they thought about geothermal from mine water. There's a lot of quite positive words on this slide, although fracking is still there. But there are people saying, oh, it's good, it's interesting, maybe it's sustainable, maybe it's friendly, natural, that kind of thing. So we can see a real difference here between the deep geothermal associations versus the mine water association. Saying that, they then asked people again, after they'd given them some information on how geothermal from mine waters actually works. And some of the words become, we've still got some very positive words, but we're also seeing words like expensive. We're seeing a few, words like disruption, disruptive. And so we're seeing a few sort of slightly more negative associations creeping in as people learn a little bit more about mine water geothermal. So anyway, so that's Derek Evanson's work. They find it's the highest of any energy development on don't know responses. People just don't know very much about it. In a lot of ways, it exists in a liminal space between renewables and gas. And this will come around again when we start to talk about our work, because it's important for that too. It's not associated very strongly with climate beliefs, unlike other energy sources. There are differences between deep geothermal versus mine water heat. And these are kind of open questions that they leave. Are there ways to frame that geothermal connection to climate change? How best to communicate about it, and also how best to explore similarities and differences from other renewables that people might be more familiar with and that they might also be very strongly in favour of. So anyway, that was a bit of a whistle-stop tour through some of the geothermal perceptions work. this is moving on to our work, which was this kind of perception spillover hypothesis, this idea of perception spillover from fracking. I don't know if, Steve, if I hand over to you, I don't know if you want to just talk a little bit about the work and kind of how it came about, things like that.
Yeah, for sure. Thanks, Emily. That was really interesting. I learned some stuff about where geothermal is sitting in the renewable picture. So that was really interesting. Thank you. Yeah, so our research came about in part because, as Emily mentioned, there was a huge controversy around fracking in the UK. It was kind of an on-off technology. The government was very much behind it. It was going to be basically trying to emulate the States and the success of fracking in the States. And the kind of political narrative was, we're going to reap the benefits of a huge shale gas resource under the UK. The government was very much behind it, but public opinion wasn't. And consistently and increasingly, public opinion was against it in an ongoing survey that the government ran on perceptions of all kinds of things, including fracking. And it became quite a high-profile issue in the UK. And as Emily said, eventually there was a moratorium. There was a de facto ban on fracking after repeated tremors and minor earthquakes that exceeded quite a low bar that was set by the advisors, the geological advisors. So basically the fracking kept on going above a certain earthquake level, and that meant they had to stop doing fracking and go back and reevaluate. And this, every time this happened, it got quite a lot of publicity, and local communities became more and more incensed about it. And there were actually national campaigns against fracking. And obviously part of that is that the UK is much smaller than the States. So these fracking sites, even if they were in relatively remote areas for the UK, that was still likely that they were close to people's homes. So yeah, in essence, fracking was super unpopular in public opinion, rightly or wrongly. And then there was this moratorium, which is still in place. And so we were particularly interested, and just to mention some of the problems, the perceived problems with fracking were water supply impacts, that it was going to poison the water, greenhouse gas emissions. Obviously, people felt a lack of control over what was going on in their local communities. People were worried about going deep underground and drilling into an unknown environment. Earth tremors, I've mentioned, and also procedural and distributional equity. In other words, how this was going to be done and who was going to get the benefits or not of it. And all these things kind of came together and were used within campaigns to have very effective campaigns against fracking. Now, because of its profile, Emily and I were discussing whether that could possibly spill over to other technologies. Often technologies are studied in isolation. So what is public opinion about a single technology? And the research is done on that basis, be it polling or focus groups. And it's also often done on individuals. So it's what is an individual's personal opinion about a particular issue. Whereas in fact, people's opinions, people's support or opposition is formed within a social context. And it was particularly this we were interested in. If a technology was perceived to be in some way similar to fracking or dissimilar, would the fracking controversy in the UK spill over and have an effect on people's opinions collectively of new technologies? So I'll just briefly speak to this slide. So, I mean, our hypothesis was that fracking was a controversy that would potentially spill over to other technologies. We wanted to explore the extent to which a similarity of the technology or dissimilarity was important or not to that spillover process. And we conceived these three ideas of these three types of spillover. As you can see in black there, spontaneous, prompted, or primed. And the idea behind this was that some people who say were very involved in the fracking debate would probably make, if they were going to make any connection at all, it would probably be spontaneous. They'd hear about a new technology and they'd compare it to fracking. And then when those people did that, because of the social world we live in, that would likely lead on to prompted spillover in other people who are perhaps less engage with the issue, but when they hear someone saying this is just like fracking, they may themselves take on that associated spillover, and their opinions would be in relation to that other person. And similarly primed, even people who didn't know about fracking, when they heard about it and people talking about it, they might say, this new technology sounds like that, now I've learned about it, and their opinions may be formed. So those were the 3 types of spillover we investigated. And yeah, I'll hand back to Emily there.
Oh, let's get myself off mute. Thank you so much, Steve. And so, yeah, we looked at 2 different technologies, right? We wanted to look at something that was similar and something that was dissimilar. And so partly because of the background of the project that we were involved in, we chose to look at deep or enhanced geothermal systems as a kind of technology that we felt could be perceived as somewhat similar to fracking. Also, for comparison, we included green hydrogen from electrolysis. And we didn't, even though hydrogen storage could be really important, we explicitly didn't include a storage component from the hydrogen, just to sort of differentiate it from these kind of underground techniques. And so these are our key findings. And so 87% of our survey respondents were opposed to fracking. And this didn't surprise us. This was in line with government statistics. And what really did surprise us was that fracking was mentioned spontaneously within literally the first couple of minutes. As shown in Derek's work, it was for a number of people, it was one of the first associations that they came up with. We also found some other things. So we found, for example, that attitude toward fracking was actually the most significant predictor of attitudes toward deep geothermal, over and above the other variables that we chose to put in our regression model, including things like political affiliation, education, income, environmental identity, and things like that. We found that spillover, so we asked a lot of sort of why questions. We included a lot of qualitative data in this study. And the reason for that was because we really wanted to understand why these associations were being made. We found that the spillover seems to mainly influence people's opinions of technologies with similar methods. So in particular, these are things that involve drilling and involve pumping anything underground. And this goes alongside previous work on carbon capture and storage that's found something quite similar. And just sort of, as a bit of an aside, I guess, because it's not really to do with deep geothermal, but we also found that a sizable minority felt more positive about green hydrogen after being prompted to talk about fracking, due to what they saw as its actual dissimilarity against fracking. This is just comparing the different types of spillover that we looked at. And we can see that all different types are more common for deep geothermal than for green hydrogen. And we also see that spillovers for geothermal are predominantly negative, as in people are becoming more negative about the technique as they compare it with fracking. Whereas for hydrogen, they're predominantly positive. So they're going the other way. So people are becoming more positive about hydrogen because they see it as quite actually different from fracking. One of the things that we also found from our sort of analysis of the qualitative data was that part of the reason that people had these issues of drilling and pumping water underground was that fracking was used as an example of the kind of unpredictable risks that can occur with the deep underground. The underground was seen as an unknowable environment, as an opaque environment. What's really interesting was it's also seen as containing intrinsic threat, right? So it's like if we mess with it, it could come back to bite us. And that very much differentiates it from the majority of other sort of natural systems that we could talk about with people. Most of the time, natural systems are perceived as being vulnerable and in need of protection. In this case, it's actually kind of the opposite. It's like the underground isn't in need of protection. It actually contains intrinsic threat. And something else that we found that was kind of interesting is that the risk perceptions appeared to increase with the depth of drilling. So basically, the deeper you go, the riskier people find it. Now, I don't know if this is the case in the US, right? But I'm constantly hearing from people in the UK that, oh, the problem with fracking was that we didn't communicate to people just how deep it goes. People think it's really shallow. They think it's right underneath their houses. They think it's really close by. Therefore, they think it's really risky. Whereas if we actually communicate just how deep it is, then people will find it less risky. We actually found completely the opposite. We found that the deeper something goes, the riskier people perceive it to be. And again, this is because of the unpredictability, the uncontrollability, the perceived challenges of monitoring and controlling and reversing any impact. And we found that the kind of shallow geothermal that we see in places like Iceland was actually perceived really quite positively. Towards the end of the study, we explicitly started a conversation about fracking, even though it had come up like way before in like loads of people's responses. Towards the end, we were like, right, now we're going to talk about fracking. And we found that, I mean, most people strongly disliked it. It's nasty, it's horrible, it should be banned, things like this. I find this quite interesting. People saying it's a 19th century technology. People really perceiving unconventional oil and gas as something that belongs in the past. It's not compatible with a kind of vision for where we should be heading in the future. What we did find, however, was when we started talking about renewable energy in the context of fracking and in the context of all of these spillover effects that we'd already found coming through, the debate became really quite complicated and really quite ambivalent. A lot of the discourses that people came up with were clearly connected to the shale gas failure in the UK. People were asking questions, particularly about deep geothermal, questions like, is it actually worth pursuing a broad portfolio of energy techniques despite the risk? People have tend to have quite an ingrained acknowledgement that a broad portfolio of techniques is a sensible hedge against risk, and that this is something that we should be pursuing. So if we're pursuing a broad portfolio, should deep geothermal actually be part of it, even though it's got all these risks associated with the underground? People asking questions like, can deep geothermal be managed responsibly in order to predict and control risks? And again, this is clearly connected to the fracking controversy. The discourses people were coming up with stemmed directly from all of these things that they felt that shale gas really failed at. And what was kind of interesting is that even in all of these strong spillover effects and all of this negative discourse about fracking, we actually didn't find much outright rejection of deep geothermal. What we found instead was more sort of conditional support. So people were willing to consider it on the grounds that it meets particular conditions. The issue is that because of the spillover effect, these conditions might be quite strict in a lot of cases. And in a lot of cases, they're going to be directly related to shale gas, directly related to the conditions which people perceived it to have failed to meet. Right? And this, I believe, is my last slide. Yeah, there we go. And so we thought it would be useful to understand what we can actually learn from all of this, particularly for the development of deep geothermal energy in the future, and potentially the successful exploitation of at least some of this resource that the UK happens to be sitting on, right? We wrote a policy brief, which is available online, and there's a link to it on the next slide, which I'll show in a second. We came up with sort of 4 key learnings that we think we should take forward. Firstly is we need to understand the fracking controversy, and we need to take its lessons seriously. We learnt a lot from the issues around fracking, or at least we hope we learned a lot. A lot of these things actually we've known about for a very long time. They've been there in the social science research for decades. But I think that the fracking controversy and how visible and how much of a problem it was in places like the UK, I think this really made these lessons front and center and has hopefully made people take a little bit more notice. These are things like what Steve mentioned at the start. These are things like procedures, including people in decision processes. They're things like a fair distribution of risks and benefits, making sure that things are perceived to be distributionally fair, and noting that community benefit payments actually didn't work in the case of fracking because they were just kind of perceived as bribes. It's also things like using the right technology in the right place, doing desk-based research before going into an area. We identified quite a lot of sort of latent or underlying spontaneous associations between fracking and deep geothermal. And this is really important because it leads us to argue that we shouldn't actually attempt to downplay the similarities, because in a situation of latent associations, there is a high risk of backfire if people feel that they're being misinformed. Thirdly, we need to get the conditions right. This is that conditional acceptance that I mentioned on the previous one. Again, a lot of these stem from what we learned from the fracking controversy. But one of the most important conditions is the perception of a general shift away from fossil fuels. In our study, this was probably the key issue which differentiated deep geothermal, which had all of this conditional acceptance and these kind of ambivalence, from fracking, which people just generally completely disliked. Derek Evanson's other work also shows that perceptions of gas are increasingly linked to perceptions of climate change. And so this notion of shifting away from fossil fuels is becoming increasingly important. And that's what I was saying earlier about how do we communicate this role of deep geothermal as actually a renewable energy source. And finally, along this line of shifting away from fossil fuels, we argue that it's important to commit to coherent policy narratives. Perception spillover is not necessarily something that you can just sort of communicate around, and actually trying to do that could run the risk of backfire. So we argue that it's better to openly acknowledge it and attempt to move past it. And one of the ways in which you can do that is to support climate narratives which commit to the phase out of fossil fuels. And this in turn would help to avoid perceptions that something like deep geothermal is just simply a non-transition. And so, yeah, so Steve, do you have anything further that you want to add before I wrap up?
No, I don't think so, Emily. I think that's covered everything.
Okay, cool. And yeah, so here there's a couple of codes you can access our work. So on the left is the policy brief that we wrote with our key conclusions and those like lessons from the last slide. And then on the right is the paper in Nature Energy. So yeah, thank you ever so much for listening. And yeah, we welcome your questions.
Thanks so much, Emily and Steve. Does anyone have any questions for either of them? I found it very interesting, Emily, the discussion about not trying to talk around it. I remember a few years back that there was a big movement, it seemed like, to talk about it as hydro shearing rather than hydrofracturing, to try and differentiate us from the oil and gas industry. Can you expand on that a little bit in terms of your thoughts on how to best approach that?
Yeah, I mean, I think I'm going into conjecture a little bit here because I don't think I'm not really a sort of communications expert, and there are a lot of communications experts who have worked really hard on this, right? But I think that, people have a very strong sense for when information that they're being given is, trying to paint too much of a rosy picture or trying to kind of paper over the cracks. We saw that a lot in the UK, at least in the fracking controversy, where the sort of communication technique that were being used by the industry and particularly by policymakers in support of fracking were not only widely dismissed, but they were also used by people to feel like they weren't being given all the information, like they weren't being given the whole truth, right? And so I think it's really important that in our attempts to use the best communication mechanisms that we can, we need to be careful that we're being as completely open and transparent as possible. And I will say that, you know, a lot of certainly the Cornish industry, you know, some of the kind of communication tools that they've been using, I think have actually decided to do this. You know, for example, they've decided to confront the issue of induced seismicity head on and actually get the community involved in measuring induced seismicity themselves, rather than just sort of saying, oh, but you know, the data tells us that induced seismicity is not a problem and you don't need to worry about it. They've kind of gone the other way around it. And I think that's the kind of thing that I'm talking about, if that makes sense.
Yeah, that's great. Thank you. We have a question from Anne Garth. Have you considered doing similar work in the US?
I mean, I don't have any money.
Oh.
Yeah, I mean, yeah, so I said that a bit flippantly. So I've got some colleagues at Cornell who are doing some really, really interesting stuff. I couldn't present it because it's still stuff that they're working on. They're still kind of doing data analysis, so they didn't want to share it just yet. But yeah, so they have two sites. So they're looking at a lake geothermal project in Ithaca at Cornell University, and they're also looking at the Cornish case. And so they're doing a sort of compare and contrast between these two things. And one of the things that they're looking at is the case of spillover from fracking in the US. And they're doing, I think they're doing New York State, but they're also doing another state, I believe. I think it might be Pennsylvania, because I think the comparison between the different states in the US is something that's really interesting, because so many different states navigated the fracking issue so completely differently. And so, yeah, look out for Catherine Lambert and Catherine McComas at Cornell. They should have some really good work on this coming out like quite soon.
That sounds great. We have a question from Wendy Fenner. What is the perception of closed loop geothermal systems that don't fracture? Do you have any insight into that?
I want to check that I'm not talking over Steve. Steve, do you want to come in on any questions?
No, please go ahead, Emily.
Oh, well, the short answer is we didn't study it. We didn't look at that in this project, so we don't know. None of our participants mentioned it. Some people did start talking about mine waste. And I think that's partly from the location of our study, which is in South Wales is where it's where we're both located, and it's where we did our focus groups. South Wales has a very, very strong history of coal mining. And that was like the major economy there for quite a long time. And so I think we did find some of that, but I think that's more connected to the location rather than a sort of UK-wide thing, if that makes sense. Steve, I don't know if there's anything you want to add.
I was just going to add that the word fracking or fracturing did seem pretty important in people's narratives, and indeed in the survey we did, people mentioned fracturing. So I think that process does have a sort of special place. So people will, if we were to estimate, I think we'd probably say that the fracking element adds to the perceived threat, and something which, I mean, as Emily mentioned, the drilling underground was also really important. So if closed loop geothermal involves drilling, that will have a certain level of kind of perceived threat, but probably the fracturing is an important element. So it's likely that closed loop geothermal is less, experiences less spillover from fracking, as you'd probably imagine.
Makes sense.
Although saying that, I will say that, you know, there's work on carbon capture and storage that have found that carbon capture and storage suffers from the same issue. And it's partly because of the pipes and the kind of pumping, and people have tried to portray CCS as like, oh, well, it's not like fracking because it's the opposite, because you're putting something in rather than getting something out. But it seems like the response to that is often like, yeah, but there's liquid going somewhere, right? So how can you say that it's not the same problems that we'll experience? So I think that, yeah, I think that Steve's right. I think that the word fracturing is a big issue. And I think that closed loop systems probably would experience lower risk perceptions, but I don't think that means that perception spillover is not an issue.
That makes sense. Do we have any last questions here before we wrap up? Okay, well, thank you so much, Emily and Steve. This has been fantastic. Really appreciate you coming in and talking to us today.
Yeah, thank you so much.
Thank you. It's a real pleasure. Thanks for having us.
Thank you. And thanks everyone for attending today.
Great. Cheers.
Great. Thanks so much. And I apologize for